Welcome back. Today we got another project here. We got two FL-2100 amplifiers, ham radio amplifiers. In fact, this one is an FL-2100 and this one is a 2277, which is a Sommerkamp model, but essentially it's the same. Both are in a rather sad state and both don't work. This one has a really awful looking front panel. We got some paint came off and it looks like it's been heavily used. So I think the channel condition of this one is actually better. So we are trying to reuse parts from the right hand one for the left hand one, but we'll decide that in a minute. So we are dealing with a few issues here. The right hand one is the Sommerkamp type. All the disc capacitors are cracked. I think that happened in transport. Someone used wire wound resistors here. You shouldn't have wire wound resistors in a PA. No, that's not gonna work. The mica capacitors look better here than here. This is my favorite here because it's generally in better condition. I need to check those capacitors for cracks, but I think they look okay so far. So that's one issue. We have some burnt components inside here as well. That needs to be addressed as well. Perhaps the right hand one is newer. We'll find that out at some point. So let's turn it around and have a look inside. So now we're inside. This is the Sommerkamp one, this is the Yaesu one. Apparently someone had his fingers here, that coil is burnt. There are some capacitors on the mains input, which is another thing that just don't like that mains input, is really dodgy. That resistor went hot, same happened here, went hot as well. Apart from that, this looks a bit cleaner here. Yeah, I think from an overall condition point we're gonna use this one. I had this before and then this one turned up on eBay for relatively cheap money. And I thought it's always good to have a few spares, especially it came with some tubes. I don't know what the state of the tubes is, but we'll find that out. We've got a tube tester and we can check that as well. So that's the underside. Let's look at the top side. So that's the top side. Sommerkamp here. Apparently someone made some marks here okay and across here, so it might be this tube is okay and this is short, who knows. Here we have the suppression coil resistor is burnt. Generally it's a bit dirtier inside. I have new capacitors for those because on these PAs it's very important that this capacitor is safe, because that isolates your high voltage from your antenna output, and I don't want to have 2 kilovolts on my antenna pin. So I have new capacitors for those. We just replaced them. They're a bit longer, but I think we have enough space to fit them here. I'm still not entirely sure which one I use, because if I look at this guy was a smoker and this guy wasn't. So anyway, on this one all the disc capacitors are gone on the back here, down here. These look okay so far. A different type here. There is the other one is not there, so something is different on those two. We just need to figure out what it is. Just close the quiet that down a little bit. And if we're really lucky, we hopefully get a pair of tubes which works, because the 522B is a bit hard to get nowadays. But since the legal limit in the UK is only 400 watts, you're not gonna stress those tubes anyway. So let's dig a bit deeper into the units here and figure out what's wrong. We need to look after the power supply as well, because I think the capacitors are not fresh anymore. I don't know how old the units are, but they are pretty old. They were in the catalog when I was young. So what we certainly need to do is actually sort out the PTT connection here. We're gonna fit a low voltage relay so we can trigger that with a model transceiver, rather than frying something here. So that's one of the things we need to address for sure. Alright, let's dig into it and see what we find. Well, we found another one. Someone replaced those resistors here, and these are burned. This one is okay, but this one is burned. And also, the safety switch is missing. It's here. That pushes down from the cover. It shorts it by a resistor. Maybe the switch was gone, I don't know. We'll find out. I think we decided what we're gonna do. We just found a serial number label. That's 303179, and this one is 303130. So this is a little bit older. That's the Sommerkamp and that's the Yaesu one. Because I think in overall, even if it's dirtier, this one is in better nick. I think it's less work to get that back to life, and the front panel looks better as well. So let's go for this one. Alright, let's start with the resistors at the rear and also the suppression coil here. So I think we found the main reason for the smoky stuff here. Don't know if that's visible on camera, but this electrolytic here went pop, and there's a lot of burnt stuff inside. The micas are actually okay, they just got the whole lot of this thing here, and I think that's got a short now, and that's causing a lot of issues. So we're gonna replace that, clean all the micas and check them, replace those resistors. That sits on the back here, so I have to take that terminal off, and we'll see where we get. So we got the drawing. These are the two resistors. It's actually the great resistors, and these are soldered directly on the socket. They're fine. This is the capacitor. It says 2 microfarad 25 volts. We'll find something for that. And that one doesn't look very nice either. This L-R combination looks alright to me. It doesn't look burned. And these are the output chokes where the resistor is burned inside. So we're gonna fix that. It makes sense because when I turned it on first, it was drawing a lot of current. That means the grid was probably pulled down to ground from this one here. We got it almost out here. It looks pretty burned, but it's not. We'll check them, we'll clean them. They look okay, I think. Otherwise I may have some. So we pulled all the old stuff out here. Some lights, and everything looks okay so far. That's the old capacitor. Popped well, so we need to restore that a little bit. Probably replacing that capacitor as well. The micas are fine. We made a resistor up 47 ohms parallel with 2 times 180. That's about 33 ohms. It's exactly the same figure as the other two, so that should be fine. And now I'm gonna solder that back together. So we got all new caps here. I left the old one in, just put another 10 nano because I didn't have a low impedance one, so I just left it on. I think it's okay. It's just a bit dirty. New capacitor. I increased the voltage rating from 35 to 50 volts because I think that's what it killed, because there were some spikes on it. Alright, let's put that back together. So everything back together. Everything is solid. Be careful with the distances, make sure there is enough distance here. From what I can see, everything else looks okay. The next one will be the output capacitor, because it's still okay, but yeah, as mentioned before, no one wants 2 kilovolt on the antenna wire if that thing fails. That's the suppressor here, and the resistor is completely split, so I think that's infinitive. You can't check it without desoldering it, because the coil obviously has less resistance. The other issue is we got some new Russian capacitors. Don't know if that's visible, but it starts cracking around here. This is a Russian, so the original capacitor is 1 nanofarad, 1000 picofarads at 3 kilovolts, and this is a Russian one which says 1000 nanofarads at 12 kilovolts. So that should be okay. It's a bit thicker than the original one. It does, size wise it would fit. The problem is the thread is not M3 or whatever that is. I need to figure that out. So I need to make a little adapter stud which makes these two threads fit into each other. I have another one which I would like, because it's 1.5 nanofarad. The problem is the diameter is too big, so it actually falls on the axle here. So except we can, I'm not entirely sure. I would like that, because it would increase the efficiency on the low bands a little bit. Anyway, so that's what we need to do. We gotta go out to the workshop and make a little M4 or M3 or whatever that is adapter stud. This screws in here. Basically, this goes in here, and that's the output to the antenna. And this end is high voltage, and you don't want that on the other side. Alright. So we took the fans out. They're easy to dismantle and clean. They're a bit dirty, so we cleaned them. Getting this one out is a bit tricky because of the SWR bridge here. But yeah, it works. Sometimes it's pretty hard to get that bearing off. So it's better to clean the shaft at the front first, and then you can usually get it out, and then make sure the shaft is super clean. I use silicone oil because it doesn't get hard, and that usually lasts forever. Let's clean that shaft, and you can see there is a bit of a mark here. That's dirt. The rear end looks a bit better, but that's all we do. And they got bronze bearing inside here. So clean, lube, and everything should be alright. We've done one already. The other ones, they're pretty simple. Just get the bolts out. The washer went down here. Just take these two screws out here, and you can take the whole thing apart. The fan itself is just fitted with a grub screw here. Make sure that it's tight so it doesn't fall off or things like that. But apart from that, simple. Not much to say about it. In the meantime, we're conditioning some tubes here. We've got heater, 6.3 volts, and 100 milliamps at about 25 volts. So we had two other ones which were only drawing about 2 amps of heater. I don't know what's wrong with those. Something is going to be wrong. They only drawing about 180 and 50 milliamps at 50 volts. So this looks a bit better. It does not draw full current. If I put it up to about 50 volts, it should draw around about 250 milliamps, but it doesn't do it. It's just about 200 milliamps. So this one is dull as well. Let's get that done. We just heat them up for a while. They might be a bit gassy, but we'll see. Oh, they come along. That's actually the one with the X of the other amplifier. Apparently it's doing okay. Not very good, but should be okay. The other two are, I wouldn't say scrap, but they are really dull. So hopefully the next one is okay as well. We just heat them for an hour with some current, just to make sure they're not sparking when we turn it on. So we got everything back together. We managed to fit the bigger one. There's just about enough clearance underneath. I put some tape underneath as well, just to make sure it's not touching anything. But it shouldn't be touching at all, but there's clearance, and the capacitor has no conductivity on the outside as well, so that should be okay. I just like the idea to have the bigger one. Left hand tube is, I would say, rather poor. This one is not so poor. They both worn out, but they should be okay. I preheated them for an hour or so. I didn't look at the electrolytics. I'm looking for new ones. What I'm gonna do is I'm gonna charge the whole thing up for 10-15 minutes with some lower voltage to make sure it's not doing something weird or shortening or something like that. And then we just crank it up with a variac pretty slow and see what happens. I've got all the bits back in, so it should be fine. We'll see. So we applied 70 volts. That's the maximum the power supply can do. I could put two in series to get 140, but it doesn't matter. We're checking the voltage on each capacitor to make sure they're equally distributed. Same at the bottom here, here, here and here. And as long as those and those are the same, you can assume resistors are fine and the capacitors are fine, so no shorts or things like that. We're about to fire it up. I just need to rig the TS130. Don't want to do it with the icon. We have the power on the capacitors for about half an hour now. So now we're going to crank it up slowly with the variac, just to make sure nothing goes pop. We found our old container. I think it's easily 30 years old, probably even older. I bought that new when I was very young. Still works, but I didn't have anything else which needed the power, so I could live with something else, like the top one here, which is a 250 watt 6dB, or the built-in dummy load of the Rust tuner. Alright, let's hook the stuff up and see if the lights stay on or not. So now it's the moment of truth. We got our variac, and if you crank that up slowly with about, I can't hardly can see that, 50 volts, 100 volts, that's 120 volts. I think I'll leave it sitting there for a while. I got just over a kilovolt at a 150 volts mains, and it looks about right. The tubes are glowing. Lights off. I'm a bit worried about the capacitors, so we'll let that sit for 10-15 minutes at that voltage, just in case something goes pop. I'm on the plate current and there is no current drawn. That's good. Alright. Well, we got it doing something. So the problem is that the variac can't deliver the power. So that's, and if you watch you can see they're going, the heater goes down, and same here, if we key the thing the voltage goes down, but we have some gain at least. Don't worry about the absolute numbers, that meter is rubbish. So that's without PA, and that's with the PA, so we've got about double, which is okay. I need to sort out the main supply, get rid of the variac. I'm gonna leave it running for a while just to make sure everything is okay. Probably we're at about 2.3 kilovolts in idle, so don't know if that's visible. Maybe some glare. I think that's good. You can see how much it drops. That's because the mains is dropping. We're only drawing about 100 and, well, make that 150 milliamps with the given drive. I can't drive it anymore, but I only get about 30-40 watts in it because the input SWR is really poor. I need to check that as well. Yeah, but apart from that, that was 20 meters. Probably check it out on 180 or so, see what it does there. Alright, not too bad. We'll check the signal with the spectrum analyzer just to see how it looks like, but I think it's okay. We need to get the covers on. It's all, be careful, be very, very careful. This is 2 kilovolts live, so you don't want to touch that. Everything looks okay, so I put the cover back on, so at least that is covered. The problem is still that if you go down there, here, that's all high voltage as well, so don't touch that either, because it may hurt you. For the PTT, I just hooked up a little relay here. Don't know if that's visible. Which basically shorts out the contact on the back and uses my PTT output on the Kenwood. Alright, that should be it from the FL-2100 for today. We're going to do some fine tuning and a couple of other things, get the covers back on and play a little bit with the settings and things like that. Just see what the tubes are like. One tube is okay, the other one is really, really poor. So I'm not going to expect a lot of power. Maybe 300 watts or so. I think one of them is still gassy. I can see some light, some blue light in there. So there might be still some gas. Alright, that's enough for part 1, I think. So we'll come back with some more in a not too distant future. Thanks for watching. Thanks for subscribing. Until next time.